Experiment 9 is about reactions of organic molecules. Objectives of the experiment are to identify functional groups in organic molecules using standard and known chemical tests, and to determine the identity of an unknown organic molecule using chemical tests. The unknowns are assigned according to the last name. If your last name starts with A to F, you're going to be using only unknown A. Last names G to L, unknown B. Last names M to R, unknown C. Last names S to Z, unknown D. You're just going to be using one unknown. First part of the experiment is part A, which is solubility in water. I'm going to place 10 drops of the sample in a tube and then add 10 drops of water and then mix it. Observe and record the results. Lab report, the first part is you're going to do this part, then write observation, and then is it soluble or insoluble in water. So if it's soluble, you will see only one layer. If it's insoluble, you will see droplets, and it's like a mixture of salad dressing like oil and water. So that means that it's immiscible or insoluble in water. We have 6 samples: hexane, toluene, ethanol, diethylamine, acetone, acetic acid. So hexane, toluene, ethanol, diethylamine, acetone, acetic acid. So I already have tubes in here. I have 6 tubes. And we have 4 unknowns. So I put already unknown A, B, C, D. It's going to be one of these. And you're going to be assigned one unknown, so you're only responsible for recording that unknown. So if you're assigned A, you put A, B, C, or D. So only one unknown for each one, for each student. I already added 10 drops of each of the sample in each of the tube. I already labeled. Okay, and then also the unknowns, and then I'm now going to add water. So this is water. This is RO water. So I'm just gonna add 10 drops of the water, hexane over here, and then 10 drops. Mix a little bit so you can see that layer on top. Okay, so this would now be insoluble or immiscible. So hexane and water. Put at the back, and now I'm going to do toluene. So toluene, again, I'm doing 10 drops. So okay, and then mix a little bit, and then again, this is the toluene. Okay. And now I'm doing ethanol. So ethanol sample, 10 drops. So I'm gonna vortex it, mix a little bit, and now we're gonna see, okay, ethanol. All right. So now next one is diethylamine. So again, 10 drops. So I'm going to mix it here. And now okay, You see a layer or no? And now acetone. So acetone sample. And again, 10 drops. Okay, so I will vortex, mix it up, and now, sorry, so acetone here. Okay, do you see a layer or no? Last sample is acetic acid. Okay, so again, 10 drops water. So okay, so that's the sample, and gonna vortex a little bit, okay, and then this is now the sample. All right, okay, so let's go over again. So hexane over here. Is there a layer? Is it difficult to see? Okay. And now toluene. Right? So ethanol sample. So if you compare hexane and ethanol, so hexane is on the left. All right? The behavior of hexane and toluene are actually the same. So now this is diethylamine, right? And then acetone. I see a little bit of turbidity, but is there a layer or no? And then acetic acid. Okay. So now I'm gonna do with the unknown. So the same idea. I'm going to add 10 drops. That's unknown A. Vortex a little bit. And then unknown B. Okay, and then unknown C, right, vortex, and then unknown D. Okay. So let's review the result. Unknown A and B. Okay. So They're both soluble. And then unknown C and D. Okay. They're also, I did not see any layer. They're both soluble. So all of the unknowns are soluble. Okay. So that's it for part A. Part B is now acidity and combustion. So we're going to test the acidity of the sample using a pH paper, and then we are going to test the flammability of each of the sample, including the unknown, using a splint, burning splint. And then you are going to write down the observations in this table. Acidity and combustion. So again, the same thing, the same samples, and then write down the unknown number that you had on part A, the same unknown. Okay, so we're gonna check first the color of the litmus paper, and then the pH. Write down the color and then the pH, and then identify whether it's acidic or basic. We have a pH paper in here, so there's a scale. Okay. So 1 is red, and then it becomes orange, and then it becomes like yellow, and then green, and then blue. So the more red it is, the more acidic the sample. And then 7 is yellowish, yellow-green, and then if it's blue, it's basic. So this is the scale. Okay. All right, and then we are going to compare the color with the scale. So I'm gonna put a little bit of hexane, 8 drops of the sample in here in the evaporating dish. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. And then put the lid, and then I'm gonna use a stir stick. So I will use a stir stick, and then, so I still have the liquid in here, and then I will put it here. Okay. So this evaporates fast. So the color is yellow-orange. Okay. So that was hexane. All right. So I'm gonna put a little bit. Oh no, I still have a sample in here. So I'm gonna do the combustion. So I have the match in here. So I have all of these that we had before. So actually, all right. Okay, so see the flame. Okay. So that was the hexane sample. So now we're gonna do toluene. So now I'm gonna do acidity first. So again, 8 drops. Toluene this time. Okay, sample. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I'm gonna do again with the stir stick. So I can use the other side of this paper and then stir stick. Okay. So again, it's the same. So the color is still 6. It's about yellow-orange. All right, pH 6 for toluene. So now I'm gonna do actually the same idea. And I'm gonna use this part here. Okay, so you see it's flammable, but see the difference is you have a lot of soot. So the hexane was clean. This one is dirty. It's a lot of carbon being burnt. So you can look. It's still hot. But anyway, this one was clean. And this one you can see dark. Okay? Well, we have to clean it up. Okay. So now the next sample is ethanol. So ethanol is now, again, the same idea, 8 drops. 1, 2, 3, 4, 5, 6, 7, 8. So write down the observations, alright? So that one is ethanol. So again, my stir stick. Okay. So I put little droplets in here, but the same. So it's actually the same, like 6. Okay, that's the color. Right? So I can use the other end later. So now we're gonna do the same thing. Flammability. So I'm gonna use this one here. It's lighting, but it doesn't stay. I think it's done. Okay. So it's clean, it's not dirty. Okay? It's not as combustible as the other two. Okay, so now we're done with those. So I'm gonna put it out here. Alright. So diethylamine, again 8 drops. I'm gonna use this other end of it, this paper, and dip the stir stick. Oh, okay, so now this one changed color. Okay, so this one now is about, I would say 9. Okay, so 9 is the color, pH 9. Alright, so that one was the diethylamine. And now, let's see, yeah, I still have some of these. And then I'm going to do again the combustion. So I'm going to use this. Okay, there it's a little bit of, there's some combustion. Okay, so right. So now acetone. So we're gonna do acetone. So again, 8 drops. So that's acetone, and then again stir stick. Okay, so I don't see any color change. I can also put a drop, because this is volatile, so I'm going to also do a drop. Okay, so the same color, nothing. So that was actually, again, the same color, 6, page 6. Okay. And I have still acetone in here, so I'm going to do same idea. So that is combustible. Okay. Alright, so now acetic acid. So you probably will guess what it is, right? What it should look like. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now I'm gonna use this one. So again, stir stick. So see, it's red. Okay, so the color is now around 2. Okay, so alright, now we're gonna do the last one of the sample. Is going to be, I guess I can use the match, but the match is okay, so it's not combustible. Alright, nothing. Okay, so those are our results. So this is, actually I redid the ethanol, so it's still flammable. Okay, so this is ethanol. Okay, so that one was ethanol. So now we're gonna do A, B, C, D, the unknowns. So this is unknown A. Alright, so we're testing the acidity. Okay, so I'm gonna put it here. So acidity is, for that one, is almost neutral, 6. Okay, so that's the unknown A. And then we're now going to do flammability. So flammability, so it's flammable. Okay, and then you can do, by process of elimination, the size of the flame and then the appearance of the flame. Okay, that was unknown A. Okay, so unknown B. Unknown B is now going to be this one. Okay, so unknown B. Okay, so acidity, I can use this part here. So 6. All right, not acidic nor basic, almost neutral. All right, now flammability. Okay, it's flammable. Right, so now we're doing C, so unknown C. Okay, we're gonna do acidity, so acidity. Okay, turn color. Right, and now flammability. It's flammable. Okay, and then the last one is gonna be D, unknown D over here. So again, few drops. Okay, and then acidity, so we can use the other end of this one. Okay. Okay, it's red, so you can probably guess what it is, right? So now flammability of that sample should be similar to the result earlier. Okay, for that non-sample. Okay, so okay, so I don't see any. It's not flammable. All right. All right. So that's done. That's A, B, C, D. Part C is now the reaction with acid and base. So we're going to have the same set of known samples and then the unknown that you've been working on. So you are now going to fill up this table. So I'm going to do first with 6 molar hydrochloric acid. Next one is going to be 6 molar sodium hydroxide. The same thing, hexane, toluene, ethanol, diethylamine, acetone, acetic acid, and then the unknown. Okay, so I already put all the samples, 8 drops each. And then as well as the unknown, I'm going to put now 6 molar hydrochloric acid. So 8 drops. And then we're going to mix it. So this is hexane. This is hexane with 6 molar hydrochloric acid. And as you can see, there are droplets on the side and they don't mix. So that means it's insoluble. So now I'm going to do the next one, which is toluene. So again, 6 molar hydrochloric acid, 8 drops. So actually, let's mix it up. Okay, so now you can see better, okay? So what do you observe? Okay, so write down the observation. Now I'm gonna do ethanol. So ethanol is this. So again, 8 drops. So I'm gonna mix it up, okay? And then again, so this is now ethanol. Okay, so I don't see any droplets on the side. A little bit, but not a lot, okay? Okay, so I don't see any layer either. Okay, that was ethanol. So now I'm doing diethylamine. So again, 8 drops. 2, 3. So you can see some, I saw some smoke and it's actually warm. Okay, so I'm gonna mix it up a little bit. You can see that there's smoke. Okay, if I mix it up, you can see some smoke on the side. You can see some smoke. I don't know, you can see it. So, all right. So I see here smoke. That was diethylamine. And now we're gonna do acetone. So acetone. So acetone, mix it up. So I don't see, there's a little bit of turbidity. Okay, it's a little bit cloudy. All right. Okay. So now acetic acid. Acetic acid, again 8 drops. Then mix it up. So nothing really happened. Okay. So I don't see any smoke. I don't see any droplets on the side. Nothing. All right. Okay, so now that was the 6 samples. Now we're going to do the unknown. So this is now unknown A. So that's A. Unknown A. And now, so mix it up. So now this is the unknown A. A. So it mixes. All right. No smoke. So unknown B. Mix it up. So I see some cloudiness. Okay. All right. It's not entirely clear. And then unknown C. Okay, so all right. Okay, that's C. And now I'm gonna do D. Okay. So D, nothing, no change. Okay. So that was the reaction with an acid, which is 6 molar hydrochloric acid. And then compare the result of the unknowns A, B, C, D with the standard samples. Next is reaction with sodium hydroxide. So again, I already have all the samples: hexane, toluene, ethanol, diethylamine, acetone, acetic acid, and then A, B, C, D. And then I'm gonna put now sodium hydroxide, 6 molar sodium hydroxide. So write down the observations. Okay, so I'm gonna do hexane. So 8 drops of the base. Cap it. And then, so I don't see any activity for the hexane. I see some droplets here on the side. Okay, so that's hexane. And then now toluene. So I'm doing toluene. So again, 8 drops. Okay, so right. So I have here toluene, so you can see, don't know if you can distinguish, there's some kind of separation of the layer. Okay, that's toluene. And then ethanol. So ethanol. Okay. And then again, mix it up. So this is now your ethanol. So it's miscible. And now we're gonna do diethylamine. So diethylamine is this sample. Okay, and then stir it up. And I don't see, there's a little bit of droplets on the side. So this is diethylamine and sodium hydroxide. It doesn't look like it's entirely miscible. Okay. And now we're gonna do acetone. So acetone. So then mix it up. So you can see droplets on the side here. Okay. And now acetic acid and base, sodium hydroxide. Okay. It's miscible. Okay, it mixed well. Okay, so those are the result for the base. Now we're gonna do the same thing for the unknown, A, B, C, D. So again, 8 drops, mix it up. So this one is miscible. Okay, and then we're gonna do B, vortex. I see some droplets or some separation. So you can see some separation of the layer. Okay. And now C. All right, C. Okay. Mix it up. So I don't see, there's some droplets on the side. And now D. I see some smoke. You guys see that? Okay. So now it mixed. It's miscible. Okay. So just a note here that D, which is the reaction of D with the base, it actually got warm. Just as a note here. Okay. So that's acidity and basicity. Part D, I'm just going to put 8 drops of the sample or unknown in the tubes, and then gonna add 3 drops of the reagent, Jones reagent, to each tube. Mix it, observe, and then record the color changes. So basically the last table in the lab report, you're gonna fill it. Okay, so this part here. So again, we have 6 samples: hexane, toluene, ethanol, diethylamine, acetone, acetic acid, and then the unknown that you've been working on. Okay, all right. So then I'm just going to add 3 drops of the reagent. So this is the Jones reagent here. Okay, so 3 drops. So the this reagent is actually orange in color. It's a It's chromium, has chromium in it, that's why it's orange. So I'm gonna add 3 drops on each and observe. 1, 2, 3. Okay. 1, 2, 3. 1. You hear the pop? 2, 3. It popped. 1, 2, 3. It popped. 1, 2, 3. 1, 2, 3. Okay. Unknown A. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So let's review. Okay, so now hexane, so I'm gonna mix it up. So hexane is orange in color, and then toluene. So toluene is orange in color, okay, and then now ethanol turned green, okay, and then diethylamine had some reaction. It actually has some kind of it has some reaction. It changed color, okay, and then acetone, same, and then acetic acid, same. So now unknown A, change color, blue-green, and then unknown B, same, orange, and then unknown D, same. There's some kind of precipitation sort of at the bottom. It has some layer in it, and then D, so let's see, D, same. Okay, so now you can compare. All right, so that's toluene. Toluene has a separation of layer. Toluene, ethanol, diethylamine, acetone, acetic acid, unknown A, B, C, and then D. So C has some kind of a reaction. Okay, all right, so that's basically the end of the experiment, and then you are now going to write the lab report, and please answer the questions at the last page. Okay, and that's basically it for this experiment.